So what happens is, like from the controller or from the chip, we will be sending one request to the sensor that start the conversion, for starting the conversion, and read the data and keep on storing the data into the sensor itself, because we'll be having other processes to do, because this is not related to only acquiring data and displaying, because we have a lot of other processes, a lot of other sensors. We need to manage it efficiently. So for that, instead of reading continuously, we will read whenever we want to read, and we will start the conversion. So for that, we can have a feature like we can choose one sensor which has this feature, and then simply reading the temperature whenever we want it. So we'll be having a good amount of data, and the sensor will have also some features where the sensor gives you a alert, yes, that the data is ready. So that is nothing but your data ready signal. So we'll be sending start signal to the sensor, and the sensor will start reading. Sensor will store some amount of value, and when sensor says that yes, I have stored it and my data is ready, so the sensor will send you back the signal, not the data. It will send you a signal. It will signal your controller or your processor that yes, data is ready, and you can read it from the sensor. So this is how we can read a temperature sensor, and this is how we read it. Instead of reading it continuously, we set some parameters. Based on that, the temperature calculates by itself, and it keeps the data ready. And whenever the user requests to read the temperature, let's say on my smart band I have a button, or I have a touch button. If I touch on temperature, so once I touch it, it will send a request to my sensor that yes, I'm ready to read the data. So after that, the processor will check whether the data is actually ready or not. So we are not going to read it every time. Once you touch or once you request from the band that you need to read temperature, sensor has to acknowledge basically that yes, my data is ready and you can read it. So once I get the signal, I'll be reading it. I'll be writing one piece of code to convert that raw data into my temperature data, and I'll be displaying it that okay, this is your body temperature now. With that, we can have other features also. As I said, we can keep a timer. The timer will be like, after every 1 hour I can, or after 30 minutes I can set a timer, and the timer will calculates your temperature after every 30 minutes, and it will keep on storing in your band. Our band especially we designed with the memory, one small amount of memory which stores all your reports in it. So in the form of reports, we can store the temperature. So the same principle we use for other types of features and sensors also. So let us discuss something which is new to the market, that is your heart rate and blood oxygen level. So how do they calculate heart rate and blood oxygen level? I'll just give you one brief idea, because I have worked on blood oxygen level and heart rate for more than 7 months, and the algorithm in it. So basically how it works is, let's talk about heart rate first. I will not go much deep into the biology of how your heart functions, but basically how your heart function is. Our heart is responsible to pump and depump two types of blood in your body. It pumps the blood which has oxygen in it, that is called oxygenated blood, and it retrieves or depumps the deoxygenated blood, which is the blood which is not having oxygen. So that is the primary function of your heart. It pumps and it depumps, it compresses and it rarefies your oxygen and deoxygenated blood. So it takes oxygen from your lungs. So your lungs passes oxygen to your heart, and the heart mixes your oxygen with your blood. Again, I'm not going in deep like how it mixes and all. Just I'm giving you an overview of how a heart functions. So this is how your heart works, and this is the main function of your heart. So what happens is, how to calculate heart rate. So what we have done is, we have chosen one special type of transmitter that actually transmit one special type of light, and that light and that particular sensor, you need to keep it on your wrist, or maybe that sensor you need to touch it by your finger, or wherever you have a proper blood circulation in your body. Keep in mind, it should not be placed on your bones. It should be placed somewhere on your body where you have, good blood circulation, or where you have veins and arteries properly. Okay, so how it works is, we'll be keeping the sensor on, let's say I have a band based sensor, so I'll be keeping it on my wrist, and we'll starting one special type of LED sensor. That LED sensor will actually penetrate my skin, and it will go inside, and let's say I have a vein which carries blood. So, and then just below that I have bones. So it will go and it will reflect from the blood, and then I'll be having a special type of receiver, that light receiver. So I have a special type of LED, I have a special type of light receiver. So basically I have special type of transmitter, I have special type of receiver. So I'll be transmitting data, I'll be transmitting some kind of light data, and your blood is basically made up of RBCs and WBCs, that is red blood corpuscles and white blood corpuscles. Your white blood corpuscle WBCs are responsible for your immune systems and a lot of other things, and your red blood corpuscles are actually related to carrying oxygen and carrying other vitamins to your body. So what basically happens is, whenever you transmit any light signal, your RBC, red blood corpuscles, they're going to absorb some amount of light which you have transmitted. So what happens is, whatever data we receive in our receiver, that is in the form of that gives us the randomness, and that randomness is based on your heartbeat. When your heart pumps, at that time we'll be reading, or we'll be getting some different value in our receiver, and when your heart retrieves the blood, at that time you'll be getting different type or different value in our receiver. So we'll be having different rate of values which we are getting in our receiver. So yes, these are the raw data that we are going to get. And again, heart rate is calculated as beats per minute. So we have to run this algorithm for 1 minute. So for 1 minute, we have to keep on monitoring the data. With this data, we'll be getting some raw value, and these raw values, we actually put one strong digital signal processing algorithm we have designed, so that you might have seen in ECG graphs that how our heart beats. We have a big wave and then we have a small wave. So we actually calculate the thrust of that big wave, and we calculate that how many thrusts are there in a single minute. So based on that, we calculate heart rate of a system. So again, for this band, the system will be same. Whenever you request heart rate